Today we're covering section 2.5 of our BJU Press Pre-Calculus textbook. We're going to discuss how to factor higher degree polynomials. So we're going to learn a method called synthetic division that will help us divide polynomials that we're used to using long division for. We're also going to learn some theorems. There's something called the remainder theorem and the factor theorem. And all of this is going to help us factor polynomials that have degrees greater than 2. So let's look at example 1. This one we have a polynomial 2x to the 5th plus 3x cubed minus 7x squared plus 3x minus 4. And we want to divide that by x minus 2. What we've learned previously is that if we want to divide this, we have to use long division. We have to think, what can I multiply x by to get 2x to the 5th? Well, I would have to multiply by 2x to the 4th. 2x to the 4th times x is 2x to the 5th. 2x to the 4th times negative 2 is minus 4x to the 4th. And we're going to subtract that, so we're going to have to distribute a minus to both. So 2x to the 5th minus 2x to the 5th cancels out, and then our minus 4x to the 4th. There's no x to the 4th term, which means we just have a minus negative 4x to the 4th, which is positive 4x to the 4th. Then we bring down our next term, which is 3x cubed. So then we think, what can I multiply x by to get 4x to the 4th? Well, I would have to multiply by 4x cubed. So 4x cubed times x is 4x to the 4th, and then 4x cubed times negative 2 is going to become 8x cubed. So this should be a minus 8 right here. Oh, there it is, minus 8 right there. Good. Okay, so now we're subtracting. So this is going to become minus 4x to the 4th, and this is going to become minus a negative, which is going to become positive or plus 8x cubed. So we end up with 3x cubed plus, because of the minus negative, and we end up with 11x cubed. We bring down our next term, which is minus 7x squared. So we think, what can I multiply by x by to get 11x cubed? I have to multiply by 11x squared. So 11x squared times x is 11x cubed. 11x squared times negative 2 is negative 22x squared. I'm subtracting that, so negative 11x cubed, and then I get minus negative 22x squared, which becomes plus 22x squared. So negative 7x squared plus 22x squared becomes 15x squared, and then I bring down my next term, which is at plus 3x. So then I think, what can I multiply by x by to get 15x squared? Well, I had to multiply by 15x. So 15x times x is 15x squared. 15x times negative 2 becomes minus 30x. So I'm going to subtract both. So negative 15x squared cancels like it's supposed to, and then minus negative 30 becomes plus 30x. So I end up with 33x. Bring down my next term, which is that minus 4. So I think of, what can I multiply by x by to get 33x? Well, 33. So 33 times x is 33x. 33 times negative 2 is negative 66. I subtract both of those, so I end up with negative 4 plus 66, which leaves me my remainder of 62, because there's nothing else that I can bring down. What if I told you all of that work can be done an easier way? There is something called synthetic division, and it's a shortened version of the same algorithm or the same steps that we use to do long division. However, the reason that it works is that it leaves out the repetitive portions of the problem without deleting the important information, such as the answer and the remainder. So synthetic division is super useful to us because it's going to quicken the process. It only works when you're dividing by a binomial of the form x minus a, okay? And And first, we're going to use a, not negative a, as a divisor, so that addition can replace subtraction in the synthetic division process. So if you have something like x plus a, and you need to convert it to x plus negative a. Also, we want to write the coefficients of the dividend on the first line, making sure to represent each power of x. If there's a power of x that's not represented, we're going to go ahead and write a 0 for their coefficient. So let's look at an example. Let's say we want to divide 9x squared plus 6x to the 5th minus x plus 12, and we want to divide by x plus 1. So what we want to do is we want to represent each coefficient, and we want to make sure that it's in order. So the highest degree is the x to the 5th, and the coefficient in front of that is 6. So the next degree should be x to the 4th. There is no x to the 4th, which means the coefficient in front of x to the 4th is 0. Our next coefficient, or our next term should be x cubed. Again, there's no x cubed, which means that the coefficient is 0. Our next one after x cubed should be x squared. There is an x squared term, and the coefficient in front of it is 9. Our next term, or our next degree, would be just x to the 1st, or just x. In this, look at this. This is a trick. You see how this says minus x? So the coefficient is negative 1. And then, of course, our last number needs to be our constant term. We do have a constant term. It's 12. If there wasn't a constant term, then that would have been a 0. So this is all of our coefficients. And notice that how each degree is represented by a coefficient. So now we want to place our a value. So remember, our binomial needs to be in the form of x minus a, and it's not. We have x plus 1. So if I were to rewrite this, this is the same as saying x minus negative 1. So our a value is going to be negative 1. So what I'm going to do is I'm going to think about the same process as division. The first thing I want to do is bring down my 6. And I'm going to multiply my a value by this line here. So negative 1 times 6 is negative 6. I'm going to place that on my next line. And then I'm going to add going down. So 0 plus negative 6 is negative 6. Then I multiply again. Negative 1 times negative 6 is positive 6, and that's going to go right here on the next line. Then I add 0 plus 6 is 6. Then I multiply. Negative 1 times 6 is negative 6, and it goes here. And then I add 9 plus negative 6 is 3. Multiply. Negative 1 times 3 is negative 3. Add. Negative 1 plus negative 3 is negative 4. Multiply. Negative 1 times negative 4 is 4. Add. 12 plus 4 is 16. So what this does is that this gives us, this line right here is our answer. Okay, this is our answer or quotient. It doesn't look like one, it just looks like a whole bunch of numbers. But these are actually coefficients to the answer. So we're always going to look at our highest degree, which in this case is the 5th, and our answer is going to be 1 degree lower. So if we started with x to the 5th, that means our answer is going to start with x to the 4th. So our quotient is 6x to the 4th minus 6x cubed plus 6x squared plus 3x minus 4, and then our last number is always going to be our remainder, and our remainder here is 16. So let's do another example. Let's use synthetic division to find the quotient of 3x cubed minus x to the 4th plus 3x minus 7, and we're going to divide by x minus 1. So in this case, our leading coefficient is negative 1 for the x to the 4th power. Our next degree is x cubed, and the coefficient in front of that was 3. Our next power would be x squared, which doesn't show up, which means the coefficient is 0. Our next degree should be the first degree, which is that x term, and the coefficient in front of that is 3. And then our last number is always going to be our constant term, which is the negative 7. So we already are in x minus a position, which means our a value is 1. So now we're going to use synthetic division. So remember, you always pull down your first term, and then you multiply. 1 times negative 1 is negative 1. 3 plus negative 1 is 2. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. And then negative 7 plus 5 is negative 2. So now we have to write our answer. Remember, we go down a degree. So our degree of our that we were dividing into was the 4th degree, which means our quotient, or our answer, is going to start with the 3rd degree. So we have negative 1x cubed plus 2x squared plus 2x plus 5. And then our last number is always our remainder, so we get remainder negative 2. Let's do another practice problem using that. 11x cubed minus 3x to the 5th minus x plus 7, and we're going to divide by x minus 2. So here are our leading coefficients, and here's our a value. So notice this was x minus 2. So remember, we want to be in the form of x minus a, and so we can identify our a value. Well, it's already in the form x minus a, which means our a value is simply 2. So we bring down our first term, which is negative 3. 2 times negative 3 is negative 6. 0 plus negative 6 is negative 6. 2 times negative 6 is negative 12. 11 plus negative 12 is negative 1. 2 times negative 1 is negative 2. 0 plus negative 2 is negative 2. 2 times negative 2 is negative 4. Negative 1 plus negative 4 is negative 5. 2 times negative 5 is negative 10. And then 7 plus negative 10 gives us our negative 3. So this becomes our quotient. Remember, we always go down 1 degree, and that last number is always our remainder. So let's talk about a theorem called the remainder theorem. So the remainder theorem says that if a number a is substituted for x in p of x, the resulting value p of a is equal to the remainder obtained when p of x is divided by x minus a. So what this is saying, let's say you have a function and you want to know evaluate when x is equal to 7, right? Well, depending on the function, it could take a really long time to do that operation. We might have to square and cube and then multiply. However, if you use synthetic division and you let your a value be 7, you simply have to use synthetic division and see what your remainder is, and that's what p of 7 is going to be, or what your answer is when you let x be 7. So let's use an example of that. Let's use the remainder theorem to find p of 3 when p of x is equal to x cubed plus 2x squared plus 4. So first of all, we want to list our coefficients. And once we have our coefficients, we need to figure out what our a value is. So remember, we're evaluating when x is 3, so we're going to let our a value be 3. So we use synthetic division. We bring down the first term. 3 times 1 is 3. 2 plus 3 is 5. 3 times 5 is 15. 0 plus 15 is 15. 3 times 15 is 45. And then 4 plus 45 is 49. So our remainder is 49, which tells us that if I were to plug in 3 for x, and do 3 cubed plus 2 times 3 squared plus 4, I would get the answer 49. Let's do another problem just like that. We're going to use the remainder theorem to find p of negative 3 when p of x equals 2x cubed minus 5x plus 7. So in this example, our a value is minus 3. So we bring down our first term, and we use synthetic division, and we end up with a remainder of negative 32. So that means that p of negative 3 or if I were to plug in negative 3 for x, I would get the answer negative 32. Our next theorem is called the factor theorem, and this says that P of A is equal to 0 if and only if x minus a is a factor of P of x. So remember, P of x is a polynomial, and we always want to factor polynomials. That's something that we're constantly asked to do. Factor this polynomial, factor this polynomial. Well, we can use our synthetic division to help us factor it. Because if we can show that x minus a divides into our polynomial, then that means x minus a is a factor of that polynomial. Okay, so let's try one. Let's factor P of x equals x cubed plus 6x squared minus x minus 30 to find the roots or the zeros of P of x if we know that P of 2 equals 0. So we know that P of 2 equals 0. That means x minus 2 is a factor of our polynomial. So let's go ahead and use synthetic division. Since P of 2 equals 0, that means our a value is 2. So when I divide by 2, I should theoretically not have a remainder because it's supposed to divide into evenly since it's a factor. And it does. So what I'm left with, though, is important, right? I'm left with 1, 8, 15, and remainder 0. So remember, that right there is our quotient, and it goes down a degree. So that means that it's x squared plus 8x plus 15. So we now have it factored slightly. We know that x minus 2 is one of our factors because it divided evenly, and then it left us with x squared plus 8x plus 15. So this times this is equal to our original polynomial. Well, x squared plus 8x plus 15 can also be factored because that's a quadratic, and that gives us x plus 3 times x plus 5. So now I have this polynomial, which was of a degree 3, and I was able to factor it using synthetic division. So since I know my factors, I can get my roots. Let's try another one. Let's say that we have this polynomial, and we know that one of our factors is P of 3 equals 0. So remember, our a value is that 3. We use synthetic division, and we should be checking that it gives us 0 for our remainder, and it does. And we're looking at that resultant quotient, which is x squared minus 9x plus 20. And then we factor that to get x minus 4 and x minus 5, which means our roots are 3, 4, and 5. Okay, so we can also work backwards. Let's say we want to find a polynomial with the integer coefficients and the following zeros. We want to assume single zero, so there's no multiplicity, unless they tell us. And that just means that the factors repeat themselves. So the zeros of P of x are -1, 5/4, and 3. And 3 has a multiplicity of 2, which means that that factor happens twice. Okay? So if these are the zeros, remember the zeros are x minus a. So x minus -1, which is x plus 1, x minus 5/4, and then x minus 3, but it happens twice, so x minus 3 squared. So all we have to do now is multiply these together. It looks like we went ahead and killed this fraction. So instead of saying x minus 5/4, we multiply everything by 4, and we get 4x minus 5. We multiplied these two together, and we got 4x squared minus x minus 5. We did x minus 3 squared, which is not x squared plus 9. You actually have to FOIL that or box method that, and that gives us x squared minus 6x plus 9. Then we multiply these two trinomials together, and we end up with our final answer of 4x to the 4th minus 25x cubed plus 37x squared plus 21x minus 45. All right, those are all of the examples for this lesson. Go ahead and try the problems.